Hello, dear students. In the previous lectures of general principle and processes for isolation of elements, we have already studied two particular important steps, that is concentration of ore, then isolation of crude metal from concentrated ore. These two steps we have completed, that how to do different kind of processes on different type of elements. But still we have crude metal. After the second step, still we have crude metal. Mean to say impurities are still 5-4% impurities are still present there. That is crude metal termed. Okay, like sulfides, silicates, iron oxide, such kind of and some foreign native elements also available in remain after isolation. So that's why impurities still exist in there. So that's why we do the last step, that is refining. Mean to convert the element completely in pure form. So third step we are applying refining. So it depends. There are numerous refining processes. We are discussing only generals. Out of those are generals we are applying. Like first, if we will talk, is distillation process. Distillation is a simple thing that you will heat the crude metal. You are heating crude metal. And heating up to where? Up to boiling point. Up to boiling point we will heat. Why? Because in the case here, our crude metal have metal plus impurities. Their boiling point is almost 25 Kelvin difference if there is existing between the boiling point of impurities and metal. I mean to say, there is difference in impurity. Like if you talk about zinc, there is mercury is available in there. Okay, whose boiling point is different by around about 25 Kelvin. That's why we apply this distillation process over that. That we will heat simply the crude metal. Okay, suppose our metal have low boiling point. So our metal first vaporizes, leaving behind the impurities in liquid state. Our metal become vaporized, then we will condense it. Okay, and we will get our pure metal. So that's how we will reduce the impurities to the desired level. Okay, we keep on heating, keep on our again and again heating the condensate, then we will getting more and more purified our metal. Okay, so this process is actually based on the boiling point difference between your impurities and metals. This is the quite simplest one process for the refining. Okay, next one is liquefaction, or you can call liquefaction, or simply liquefaction. As the name suggesting that liquid, mean to say now we will focus on what? Melting point rather than boiling point. So first what we will do, we will heat crude metal. Crude metal we will heat up to where? Up to melting point. So one of our, let's say metal have low melting points, so metal become liquid. Metal become liquid, and then we will solidify it to get pure metal further. So that's the whole process. That this method is actually based on the melting point difference. The same as the distillation. In both we are heating the crude metal. Just in the case of the distillation, it depends on the boiling point difference between the metal and impurities. But it's in liquefaction, the whole process depend on the melting point difference between your metal and impurities. So these are the some basic processes we apply. These processes usually applied only, I have told you that when the temperature difference between the melting boiling point is more than 25 Kelvin or 25 degrees Celsius. If That is not true. The constraint we have, that boiling point difference is not much. Then the best methods, whatever methods we are discussing, the best method is this one, that is known as electrolytic refining. Electrolytic refining, you can use this process at purification of any element particularly, and this is giving the best results, because impurities you can get almost up to 99.9% purified. So how it is working? First of all, we will take a container in which we will take the solution of the salt solution of the metal, same metal you are extracting. Like for example, we are refining copper. Okay, so we will take here a rod which is anode. You have to pay attention quite clearly. The anode is made up of what? Impure metal. Impure metal mean to say crude, that is one which you want to purify further. Now this is one electrode, cathode. And what is the material for this cathode? Cathode is also pure metal which you are extracting. Like in this case it is pure metal, copper you will take. Okay, cathode should be of pure. Now here we will take salt of the same solution, like copper sulfate. Okay, now what will happen when you will pass the current? Okay, then what will happen at that time? That copper from anode, in actual these copper 2 positive ion from the liquid will start move towards the negative electrode, that is particularly your cathode, and start depositing over here on the surface of this. And as the one ion move, that ion will start move from the anode. So at reaction is anode is happening what? Copper is converting into copper 2 positive by losing 2 electron, while at cathode copper is gaining 2 electron and getting deposited in form of the copper. Okay, so this is the whole process. So with the time you will see that anode will start becoming thinner. Okay, because copper is removing from it, and this will start becoming thicker. Why? Because it is getting deposited over here, copper. And you will see that after some times there are some sand get collected. Actually this is over below the anode. This is known as anode mud. Okay, these are also impurities like selenium, tellurium, gold, silver. Such kind of impurities are present, which is available as a anode mud. And this anode mud also is quite costly, which can meet the expense of this electrolytic refining even. So that's how you will make this process more and more efficient and economical for refining. So that's why I am telling you that electrolytic refining is the most good method for the refining of any kind of the element. Just you have to pay attention our 3 things. What is made up of anode? You will use impure metal, that is crude metal. And the metal you are extracting, same metal you need in the pure form already, which you used as a cathode. And the metal you are extracting, the salt of that metal also you will use as a electrolyte in that case. Okay, so this is the whole concept of the electrolytic. Same metal will get oxidized, same metal will get reduced particularly. Okay, now the next one is termed as zone refining. Zone refining. What is zone refining? Let me tell you. Suppose this is the crude metal rod. This is made up of crude metal, meant to say having impurities. Crude metal. Okay. Now what we are using over here, we are using a heater over here. This is a roller heater. Okay. Which can move without disturbing this crude metal rod particularly. Okay, this is what? Heater. So how it is helping in removing the impurities. On what principle it is actually based? That impurities are more soluble in metal, or metal which we are refining. Impurities are more soluble in metal we are refining in liquid state rather than solid state. Mean to say, impurities want to remain with this metal, but if it is available in liquid form, they will more likely to be that metal with. So when you move the heater, the whole this region between become liquid, so the impurities become dissolved here. So as we move this heater along this direction, so what we will see, that your impurities will keep moving with this molten state. Okay, that's how we will keep this heater up to here. The impurities will move with the heater in the liquid state, and then we will cut down the rod from that direction which have impurities, and we get our pure metal. If we do the repetition of this, mean to say, heater, we need how much refined foam we need, how much purity we need, we will again repeat this step. Okay, move the heater again and again, so that impurities can be reduced to the desired level. So the zone refining whole concept is based on the impurities solubility, in dependent on what, in liquid or in solid. This is the whole concept of the zone refining. Okay, the next one important is termed as vapor phase refining. Vapor phase refining. Okay, what is vapor phase refining? In that we use crude metal, we will combine it with a substance, you can say. When these will combine, they will form a more volatile compound, and then we will decompose it into, okay, then the process will be decomposed. So what the main two things needed? With first thing we needed that metal form a volatile compound with volatile compound. Second requirement, easily get decomposed from that. Let's take an example. Two examples are there for this one. Okay, the first one is your Mond process, termed as Mond process, in which we heat the nickel particularly. Suppose this is nickel crude having impurity. We will heat it with the carbon monoxides. So they will form nickel tetracarbonyl. Now this nickel tetracarbonyl is more volatile, mean to say can be easily separated by distillation. Okay, now when nickel tetracarbonyl we have, then we will heat it further at higher temperature, around about 500 Kelvin. It will get decomposed easily. So we get our pure nickel over here. Okay, so this is the whole concept, that first we will combine the substance with that pure metal, crude metal, to form a volatile compound. This is a volatile compound which our metal will get formed. Now, next thing, it should get easily decomposed. The next one is you have to tell about is termed as Van Arkel method. In that case, we heat particularly our metal crude like zirconium with a iodine particularly. So they will form zirconium iodide. Okay. Now this is volatile compound. Now when we heat this one particularly, it will get decomposed again, giving us pure metal behind. So this one is pure. Okay, so the same thing you see in both cases. The only difference in this Mond process and Van Arkel is the substance you are using to form the volatile compound. In the case of the Mond process, it is carbon monoxide. In case of the Van Arkel method, it is particularly your iodine. So far we have discussed 5: distillation, liquefaction, electrolytic refining, zone refining, vapor phase refining. There is a last process, complete one, that is known as chromatography. Chromatography, or you can say chromatographic method for refining. Okay, you have already heard about the chromatography, that it is first used to separate colors. That's how it gets its name. But today we will discuss about column chromatography, that how it is helping in refining. In the whole, this concept is based on the adsorption principle. Based on adsorption. We have already studied the adsorption in the previous chapter, surface chemistry. Adsorption principle based. How? Let's suppose we have a column, this over here column. Okay, this is known as column. At one end, it have over here a adsorbate. Adsorbate. Okay. So what we will do from here, we will pour crude metal in liquid. First we will convert our crude metal in liquid, then we will put that over here in this column. Then what will happen, this adsorbate particularly will adsorb either impurities or either metals. Suppose impurities get adsorbed. So you will see that impurities will start collecting over this adsorbate, and our crude metal, pure metal will pass to the next level and we will solidify it. So the whole concept is based on the adsorption principle. So you will use a adsorbate which is either work for metal. If our adsorbate is have adsorption power selective for the metal, then our pure metal will get collected over here, impurities will move out. So that's how we are using chromatographic method. So I am again repeating you that distillation, particularly boiling point based, liquefaction melting point based, electrolytic refining okay, delta G concept it will work on minus NFE. Okay, D, your zone refining work on what? Impurities solubility concept based on E, chemical processing kind, that is your zone refining, vapor phase refining based on what? Forming volatile compound, or you can say simply chemical principle dependent. And F, last one, chromatography, is based on adsorption principle. So this 6 process we have discussed so far, okay, for the refining. These are the some general processes we will apply. The whole chapter is telling you that we are discussing general processes and principles. So these are the various general processes we use mostly to refine particularly our crude metals. Okay, now the last topic of this chapter is applications of metals. So you know that very well, that metal is used to form a large number of compounds. Like iron is vastly used to cast many things, like bridges. Okay, bridges are made up of iron. So cast iron we will use particularly over there, pig iron. And to form the alloys, because alloys have great properties. Okay, or you can say enhanced properties. Like if you talk about brass, brass is a mixture of copper plus zinc. Okay, German silver, if you will talk, this is copper, tin, and nickel particularly. So there are different kind of alloys. Zinc is also used for the galvanization. Galvanization is to stop the corrosion, particularly for the iron. So different metals have different application in different fields. So that's why we are first thing purifying or need the elements metals in pure form. So that's the application of metals, particularly a different kind of alloy is also given in your book, particularly. So today your chapter, this one is comes to end, particularly because this is the last topic you did. Okay, now your homework is first to read the complete chapter. Okay, and today I am giving you notes, complete chapter. Okay, thank you.